law of conservation of momentum. Previously, in step 1, we defined that change of momentum is given by impulse of force in time interval from t1 to t2. So there is a change of momentum. And if we want to keep the momentum of the system constant, so this equals 0. So it means that this right side of equation is equals 0. So if the right side of equation is equals 0, the left side of the equation must be equals 0 too. So the condition for keeping momentum constant is that impulse of force acting to the particle in certain time interval is equals 0. So this is condition of this law. Okay, we can ensure this requirement in two ways. For example, we can say that there is no force. Okay, so integral of 0 can be 0 too. So it's okay. But B, for example, F can depend on time in such a way that integral of this function in certain time interval is equal to 0. So let's show such an example. So there is a time, there is 0, why not? And there is some function ft. So let's say that it is a sinus wave. For example, there is amplitude plus minus f0, and this is a period time 2, and t1 is equal to 0. This is a half of a period, a quarter, and this. So this is a function sinus. Okay. So if this function is, for example, sinus, and we make an integral of this function in time, so we get, by integrating this function, we get the area of the curve. So because this is the same area as here but with negative sign, so plus minus compensates itself, and the total integral is equal to 0 finally. Okay, so in certain time, from starting time to end time, there can be some force. It's not necessary to have a force 0 for all the time, but integral of this force must be 0 to keep the momentum constant at when we compare state 2 and state 1. So then, if this is applicable, so then P2 minus P1 is equal to 0, and it means that mv2 minus mv1 is equal to 0, mv2 is equal to mv1. So if mass is constant, we can cancel mass. For mass is constant, we get that final velocity is same as the starting velocity. Okay, so this is a subsequence of law of conservation of momentum.